So, good afternoon once again, everyone, and thank you so much for joining in today. It's a pleasure to have you all along with us. And once again, thank you for taking out your time from your daily busy schedule on a weekday. I hope we can make the most of the next 1 hour. So today's topic, which we have chosen is to focus on how power quality can impact reliability and safety of electrical systems, and what can be done to ensure that we can preempt or predict these issues with respect to safety and reliability much in advance, so that we are left with a much healthier electrical network system when we are, or whichever type of facility we are working in. Very briefly, I won't bore you with what we do, because a lot of you already might be aware. We are Efficienergi. We offer for uh, expertise and tech applications for commercial and industrial electrical networks, for ensuring the safety and reliability of these networks by working with cutting edge tools such as cloud and mobile applications, along with the traditional domain knowledge that we bring, along with ensuring compliance also increases to the next level. And in our journey, we have been very fortunate to have earned quite a few accolades, such as awards at India Smart Grid Forum, ICC Awards, Maharashtra State Innovation Society, and almost enjoying the patronage of many institutions that have something to do with power and energy, like BIS, CEA, CII, FICCI, NPC, CVIP, EMA, regulators, and amongst others. And a lot of blue chip corporate companies also, where we continuously do deliver training sessions, webinars, workshops, and authoring, papers in journals, and are considered as thought leaders, humbly, is what I would say. So without much ado, diving into the topic for the day. Okay, what is the scenario today that we're looking at? Okay, there is the fact that electrical safety has become a narrative which has caught on mainstream attention, thanks to our dubious records, are not so welcome records, I would say, of electrical accidents and fires and deaths and electrocutions that we, have been coming across. If I remember correctly, I just read somewhere almost 10,000 accidents in the period of 2019 to 2020. In that 1 or 2 year period, 10,000 electrical accidents is what Central Electricity Authority has captured. And mind you, these are just accidents which have been reported. Okay, a large portion of those are unreported. So are we truly complying to electrical safety standards? While the topic for today is going to be focusing on power quality largely and its impact on electrical safety and reliability, but in another session, maybe in the next few weeks, we will also take up something core related to electrical safety also. But that's the question we keep on asking, and the scenario of today is whether are we really complying to these standards? Are we having an unknown risk in terms of electrical safety within our premises? That's something is a question again that we find it wanting to be asked, and there is no clear answer. So for that, we keep on doing a lot of audits across various facilities, across various plants, various buildings, various premises, institutions, etc. And what you see on the screen is, example of the survey results that we have as to what exactly are different sample of different tests that we undertake at these facilities. And as you see, these are some of the electrical safety related tests that we typically undertake, which are also mandated as part of IS 732, CEA regulations, and so on for various buildings and plants. First, for example, residual current device test. Very simple test for checking the health of a earthing device which is provided in any premise. or not in some cases, in a lot of cases, I would say. But even for the cases where they're present, we have found that 30% of these cases, the RCDs have been found to not be performing to their true function. Either they are tripping too fast than they were supposed to, which may be a cause of nuisance tripping, or they don't trip at all, right? Or they take extra amount of current, leakage current for them to really act. So the whole purpose of the residual current device or the earth leakage circuit device gets defeated. Primary injection test, that's not a very regularly conducted test, a primary or secondary injection test on breakers and relays. But we have found that 23% of almost 40 facilities that have been part of this survey. We have done hundreds of them, but we selected a few sample set of them across different industries and so on. And 23% of these facilities had breakers or relays which were not, again, tripping as per the time current characteristics that they were supposed to. Coordination and discrimination. This, not surprisingly though, that we found that almost 60 to 80% of facilities, there is absolutely miscoordination between the HT all the way to the LT to the load end of various breakers, relays, and so on. And thermal imaging, yes, although that's been one of the areas which a lot of industries and facilities have started doing it, but still we have found in 111 facilities, 78% of them had hotspots of varying degrees. Again, this is based on certain standards, NFPA, IS standard 16168 for thermography and so on, based on these. So this gives an idea of the electrical infra health in the country today, and why we say that electrical safety is really an unknown risk, because these are the issues which are lying unattended to and unknown by hundreds and thousands of industries across the country. If I go further, right, and I delve into the topic for today, which is power quality. Are we really analyzing power quality for reliability improvement? Is a question again we have been asking ourselves. And again, this survey on your screen gives some telling figures. Okay, there are different types of power quality events, which we will talk about in a later part of the slide. But if this slide tells you about different power quality events such as voltage variations, rapid voltage changes, sags and swells, transients, unbalances, high voltage harmonics, unbalance in current, high current harmonics, right? ITHD. We will talk into, if someone is not familiar, we'll go into these in a little more detail later on. But a survey across more than 90 facilities, okay, not a small number, mind you, it's a very large sample set that we're talking about. And you see the numbers over here, 56% of them experience rapid voltage changes, which is very similar to a voltage dip or a very fast change in voltage. 47% experience transients, okay, very fast acting transients, almost in the order of a few microseconds, maybe to a few nanoseconds also. 47% of them have high current imbalance. One of the reasons for neutral currents increasing, one of the reasons for circulating currents, and so on. And current harmonics for 70% of them have been found to be exceeding certain limits set by IEEE 519 or CEA standards and so on. So this is again, a telling statistic when it comes to power quality. Why it is something that is overlooked is probably because we have found out is that the awareness with respect to these different types of events is not that prevalent amongst industry. We will speak about certain myths in a small while, but this is a survey just to open up our eyes with respect to how power quality is being manifested at hundreds of facilities across the country. So the next question comes to my mind is, have you, as a plant, as a facility, as a building, as a laboratory, I know there are different types of participants today. More than 100 we have, and I've seen that at a lot of these places there are sensitive equipments, right? It can be a CNC, it can be a variable frequency drive, it can be a process equipment, it can be a computer server, data hall, and so on. Have you faced sensitive equipment malfunctions across different of your plants or premises. Uh, for that, one of the reasons, one of the contributors for such kind of equipment malfunctions is another survey that we ran on earthing quality. So I would not say we ran a survey. These are again results from our audits and our studies that we do, tests that we do on the field on different facilities across over the years. And you can see over here that we found almost in 49 facilities, 47% of them had high incidences of ground potentials or leakage currents in the earthing network. And 70 out of 78 facilities, 52% of them had very high loop impedance, earth loop impedance, which effectively meant that the earthing was not doing the job it was supposed to be doing. The focus of the plant maintenance people or the facility management personnel is primarily on the earth pit management rather than on earth loop impedance, which sits inside the premise near the equipment to really understand whether or not the equipment earthing is healthy or not, and the protective devices will operate if at all there is a fault if it occurs. So this again is a telling statistic. It's not a small number. So that also brings me to the next one, where a question is to be asked whether you have faced an inexplicable downtime at times, right? Have you faced in your premises any time when you had a unplanned downtime, when you had a breaker tripping, a nuisance tripping of a breaker or a relay or something like that, and it was unexplained, you could not come out with an explanation? Would love to know your thoughts on that. So these are some of the things that we have faced. And last and not the least, harmonics. How can power quality be complete without mention of harmonics, right? But I think it's time that we move on beyond harmonics to also have the supra harmonics in our lexicon, in our jargon, which are coming very fast within the electrical grid of your own premises as well as the common grid. And the reason is going to be evident in the next slide. But these are primarily harmonics which are beyond the 50th harmonic, and they extend all the way up to 150 kilohertz. So when we are talking about 50th harmonic, it's about 2.5 kilohertz. So these start from the 2 kilohertz to the 150 kilohertz spectrum. That's the supra harmonics range that we're talking about, and they are becoming very much prevalent given these high frequency switching devices that we are having all across the premises. So we will have based on this, to get a sense of whether or not you have come across these kind of issues, I'm running a small poll which should be on your screen right now. It will help us to know if you have had any of these challenges experienced in your own facilities. It would be great if you could spend 15 seconds answering this. You can choose not to answer. That's also fine. It will give us an idea that fine, you have not experienced any of these. I would love to get these answers. So yeah, we have quite a few these coming. I would wait for another 5 seconds to see the poll end. And I think equipment malfunctions wins the award in terms of almost 56% of participants do say that they have experienced equipment malfunctions. Second highest is 36% is humming and overheating. Almost 35% I mentioned they have experienced that. Almost 30% have experienced all of these symptoms of safety incidents, humming, overheating, unexpected downtime, and so on. Safety incidents, expectedly, only 10% have experienced, which is, what I would say the reason why we overlook safety a lot of times. When I say safety incidents, it's not only an electrocution. It's as simple as a shock hazard, a tingling effect, and so on. It starts from something very small, and that's how it goes further. So we have, the final results. Yes, 50% of you have, experienced equipment malfunctions, and 38% of you have experienced humming and overheating. So good. I mean, it's a good, insight for us that tells us that the session hopefully will add some value and allow you to know how these equipment malfunctions or these overheating, etc., can be prevented. So at the macro level, why are these things occurring? Why are these facts which are becoming common for us, becoming a kind of chalta hai type of attitude? Why is that happening? What are the culprits which are responsible for some of these things at a macro level? So if I were to say at a macro level on a timeline, if I plot what are the things that are causing these electrical systems to deteriorate, first and foremost, I would say is our experience, my experience over the last 23 years of being in this field of electrical network testing, analysis, audits, and so on. It's a cultural phenomenon, I would say. We as a country place very, very low prominence, very low, less priority to adhering to electrical standards, except for a few top of the line industries and MNCs. The larger part of the country's industrial segments and the commercial segments, building segments, we do not adhere to electrical standards, right from the CEA regulations to IS standards to IEC standards, IEEE, NFP, and so on. Some of them are very much built for the contractors to be utilizing, for the maintenance engineers to be utilizing, but we fall short for it a lot of times. That's my reading of so many years of experience. Second are some factors which are happening. We are adding 500,000 AC drives annually, right? So these are non-linear loads, so as to speak, and that is going to cause the system to deteriorate to a certain extent. Deteriorate when I say in terms of power quality, in terms of harmonic pollution, in terms of the high frequency switching devices that are getting added in the system. 26 cities with metro projects already, 35 more cities proposed. So metros, again, non-linear load at the end of the day, and will add a burden on the grid. Okay. A mix of traditional and modern loads inside facilities. That is another reason. You have a traditional inductive loads within the facility. You have a non-linear loads sitting inside a facility. LED lamps, LED street lights, LED fittings getting replaced, and a large part of energy efficiency drives driving that by 2025. Almost 1.34 crore street lights will be replaced with LED. And last but not the least, solar and wind and EVs. These are our three core, focus areas for our net zero commitment, for our sustainability goals, COP26 goals, and so on, which is very good. No doubt about it. We can't, refute that. But yes, from a power quality standpoint, these can create a lot of challenges at the grid edge. If I talk about it, if I talk about the boundary where these distributed energy resources, these DERs as we call them, they interface with the grid, that's where the challenges are bound to multiply manifold. Okay. So worsening of these power quality indices. Okay, there is a very good study by Power Grid Corporation of India, which was done almost in 2015. I unfortunately have not included it here, but we will try and share it with the participants later on. But that study pointed out how India as a whole had power quality indices, the severity of power quality indices in almost way back in 2015. Those indices were much before this proliferation was, so heavy on all of these counts. So our worsening is going to be speeding up in the years to come, considering a combination of above factors. So now coming to power quality, right? And its difference with respect to, I would say, availability. Till now, availability was the problem that India as a country was grappling with. And that was either availability is there or it's not there, right? It's either on or off. But when I'm talking about power quality, in that sense, it is a question of depends, right? I cannot answer it rightly in a 1 or 0 or a black and white fashion, because power quality and reliability has a lot more to it than just availability of power. So what is different? The difference is in terms of the fact that power quality is multi-pronged, okay, which we'll see in just a bit. It is dynamic, it is intermittent. What is true now, while I'm speaking to you right now, the quality of power right now may be different, very different in the next minute, right? So it's very difficult to define good power quality. Is it the load compatibility? Is it the reliability of the source, and so on. Whose responsibility is it? Is it the utilities, the discom's responsibility? Is it the end user's responsibility? Is it the OEM who has supplied the equipment, his responsibility? Is it the responsibility of the contractor who's doing the installation? So on and so forth, right? And the benefits of improving power quality, of ensuring power quality remains good, it's not very obvious. So one of my mentors, okay, Alex McCaffron from US, he put this definition of power quality very succinctly and very briefly. And I hold this and I tell about this. There are definitions which IEEE talks about and so on. That's fair enough. But I think the three most important things for power quality is, first and foremost, is whether the load is sturdy enough to withstand the power quality that it is getting, right? That's the first requirement of your power quality, whether the load is good enough, is sturdy enough in itself. Second is whether the quality of power is good enough to operate the load without any issues. So the utility side or the quality of power being supplied, whether it adheres to a certain basic minimum thresholds that it is allowing the loads to operate in a reasonably expected behavior. The third is the load careful about not disturbing the power? That is the third, I would say, aspect of power quality definition. The loads themselves have to be careful about not disturbing the environment in which they are operating, which is why I was talking about these DERs and so on and so forth. So together, the definition of power quality becomes this: are the power which is being supplied and the load compatible with each other or not? That's your definition for power quality, which all of us have to strive to understand. The standards are there just to provide us a sense of where are we sitting with respect to power quality. There are dime a dozen standards. Don't get lost into the nitty-gritties and complexities of these standards. There are enough tools available, which you will see one of them today, which will automate that whole compliance to standards part, without you having to bat an eyelid. Within a fraction of a second, you can get those compliance reports. But those compliance reports mean nothing unless you really understand where power quality is hitting you, your facility, your equipment. So going a little deeper into what constitutes power quality from a theoretical standpoint, from an academic standpoint, you have on the screen various small infographic which tells about different aspects of power quality. Very quickly, if you see, very quickly, if you see there in terms of power quality, you would have frequency deviations, which come as the first one to your mind. You have voltage interruptions, which we Indians are very used to, unfortunately. We have voltage transients, ranging again, as I said, in a very, which are very fast acting voltage events, not typically going beyond 1 or 2 milliseconds. They will be over much before you can even blink an eye. Voltage dips and swells, these are in the order of a few milliseconds to dozens of milliseconds, I would say, to maybe even hundreds of milliseconds at times. And they are either a dip in the voltage or a rise in the voltage, right? Which is what a voltage sag is specifically. You have voltage unbalance, which is, as the name suggests, unbalance between the three phases of voltage. You have voltage flickers, which is a manifestation of a fast voltage change measured in terms of light intensity of how it is manifesting to the human eye. That's what your flicker is. Further, you have harmonics, which is, I believe now, a lot of education and knowledge awareness has happened in the industry about harmonics. So I'll not go into too much in detail in that. And over under voltages, which are extended period of time, you would have a slight over voltage or an under voltage happening. And last but not the least, your power factor, which also I would put it as part of the whole power quality triangle. The aspect of power quality, because it gets directly affected by harmonics, by voltage, and so on. So these, in a nutshell, is the academic aspect of power quality, what it constitutes. What does power quality constitute? What does it mean when we say that power quality is poor? Either one or many of these parameters can be deviating from their expected characteristics. So before we go into certain case studies and understanding a little more theory on one or two of these power quality events, I would like to talk about a few myths, okay, that over the year we have come across and we have experienced it in the eyes and ears and the expressions of our customers, of our audiences wherever we have gone and delivered workshops. The first myth which I want to bust, I want to call out, is that a capacitor panel, a UPS, a static voltage regulator, for example, or a stabilizer, I would say, or a harmonic filter, these are not the solutions for power quality. If you feel that you have installed a UPS, it doesn't mean that your power quality problems have gone away. If you have installed a active harmonic filter or a passive harmonic filter or a hybrid filter, whatever the case may be, it doesn't mean that you have taken care of power quality in toto and now you are immune to any power quality issues. That's not the case. Much further from that. The next is harmonics are not always harmful, right? I used to sell harmonic filters for a living in my earlier innings, my first innings, I would say. That's why I would jokingly say I got booted out from that venture, because I never was a good marketer or a good salesman, because 6 out of 10 of my customers, we used to tell that please do not do anything to your harmonics. Please do not buy a harmonic filter. Because that's not the problem that you are running after. You're chasing the wrong cat. I mean, that you need to focus on something else, which is the problem with respect to equipment malfunction, with respect to overheating, with respect to downtime, and so on. So harmonics, remember, are not always harmful. An oversized system is not always better for power quality. We have quite a few designers who will oversize the systems in terms of sizing of breakers, in terms of sizing of cables, and so on. But it can be detrimental in the real practical sense when it comes to having a downtime tripping event, when it comes to having a motor which is inefficient because of its oversizing, and so on. So it's not always good to have an oversized system for better power quality. Yes, in the right places, in terms of maybe right sizing of cables, to consider for derating of nonlinear equipment and so on, yes, I would appreciate, but not always. Fourth is permanent monitoring is not equivalent to one-off measurement of power quality. A lot of times we have seen, okay, not I would say a lot, almost 9 out of 10 times the approach that our country's maintenance teams, our facility engineers, managers, and so on take is that if there is a problem, they will get somebody to do a power quality audit. They'll ask someone, they'll get a quotation. अरे सर जरा आ जाओ ना 24 घंटे का जरा एक power quality audit करना है, कुछ तो प्रॉब्लम हो रहा है, समझना है क्या हो रहा है. They'll call someone, वो एक एनालिसिस लगाएगा 24 घंटे के लिए, not even 24 hours. I found reports of power quality audits being done 2 hours. 10 मिनट के लिए भी देखा है मैंने. 10 मिनट एक फीटर पे लगाया, निकाला, दूसरे पे लगाया, तीसरे, चौथे, पांचवे, और पावर क्वालिटी स्टडी एनालिसिस रिपोर्ट प्रिंट आउट निकाल के 200 पेज का रिपोर्ट चिपका दिया. Sorry, excuse my crude language, but that's how we have seen things happening, and that's how power quality audits have gotten dumbed down to. And what happens is people say कि अरे हाँ हमने तो power quality audit करा है, उसमें तो कुछ नहीं मिला हमको. सर आपको कैसे मिलेगा? आपने कभी कोरिलेशन आपके इंसिडेंसेस का, आपके प्रॉब्लम्स का, और with respect to the power quality monitoring that you're doing, have you truly understood what is the duration that you need to do, what are the location that you need to monitor, and so on and so forth? So our experience again of so many case studies that we have done, the 1995 number which you saw in my first slide of the survey which I included, that's just a small number of the audits that we have done. But in almost more than 50 to 60% of these places, the mandate, the requirement was to extend the time duration of the study to more than 15-20 days, because the problems were not that obvious. We had to go much deeper, which we'll see in some of the case studies. So that's why I say permanent monitoring cannot replace a one-off power quality measurement. And today I want to tell that most of the industries, most of the commercial buildings have these high-end power quality monitors already installed. What are we doing with terms of using these for allowing our facilities to become more safer and more reliable? That's a question I want to leave the audience with. Do we have electric vehicles, PVs, wind generation, and do we assume that they are not going to have any power quality issues? That's another myth I want to bust, because that's not something that we have experienced. In fact, it's almost the opposite. The more proliferation we are finding of these new age renewable energy resources, and the more they are not configured or selected properly, there are more and more issues that are popping up. So please do not expect that you are going for a clean energy source. It's going to eliminate your power quality problems. Not so, not fortunately not, unfortunately not. Additional earthing stations. This is again another thing which you have come at times. Critical equipment है, CNC machine है, वो OEMS said कि हमको dedicated earthing pit चाहिए. That is another common mistake that people make, and they dig up work pits assuming that their problems will go away, but that's not the case. You are actually worsening the earthing healthiness of your facility. It's not going to protect your sensitive equipments to add more and more earthing in the system. So these are some of the myths that we busted, and I would love to hear about your views in this small poll which is on your screen again. I'm trying to keep this interactive so we get some idea of sense of you. Have you experienced or do you face any of these myths? Have you understood any of these myths? Have you found some of these myths prevalent? Did it enlighten you in some way? That would be really great to have some ideas. Really heartening to know that almost more than 80% of you agree with these myths, have experienced these myths. That itself proves the point we're trying to make. So yeah, I think we have almost 76% telling that, yeah, you have experienced these myths. Thankful for that. So we'll go further and let's see that what can be done, for all these challenges that you're facing. So the question that comes to our mind is that do you have the tools to navigate these challenges which come across your facilities, your plants? What are these challenges that you're facing? What typically we have experienced is people have seen that they see penalties, or they see electrical fires happening, they see a downtime happening, they see equipment failure happening in your facility, or some kind of life risks which are prevalent. But what goes on to cause these are much below the energy burn, is what we call this. We call this as the energy burn. And our experience is that the warriors, if I call them, we had in COVID the medical warriors, and for me, all of these guys who maintain facilities, all of these personnel who are at the forefront manning the electrical systems inside premises are the warriors, or the electrical warriors, right? So they are more focused on these very obvious things that come to them while they are working on a day-to-day basis, but the root causes for these sit much below. Bad power quality, you call it, a compromised safety, an earthing issue, overloading, suboptimal design of the system, and so on. And they are not knowing how to go about this. So that's where we had been working on this over the last few years and tried to come out with a platform called as Secure, which is our homegrown, made in India platform called as Secure, a safety, efficiency, compliance, quality, and reliability of any facility, of any premise, of any plant, which allows anybody to navigate, first and foremost what are the issues in the energy bird, and navigate the energy bird, right? I mean, I'm just using that analogy of the energy bird to highlight how we go about this. It's been already used to monitor at hundreds of locations right now, and something that we are looking forward to engage with you if at all it makes sense for you. So again, as I said, today is not truly a marketing session. It's more to deliver some value add in terms of power quality. So let's go and deep dive into one small area of power quality, one of the events. Okay, obviously we don't have time to cover masterclass on power quality. That will require at least half a day of detailed topics and sessions. But what I want to do is I want to take up voltage sags, okay, as part of the first power quality event. And for this, before I go into voltage sags, I just want to get an idea of what kind of knowledge do you have about voltage sags among the audience. Are you aware of what kind of problems can voltage sags cause to any facility, right? So I'm just launching a small poll, which I love your answers to again. We're trying to make this as interactive. So the question is, how much do voltage sags impact the functioning of sensitive equipment in your opinion? Okay, I have not talked about voltage sags. I will be doing that. I just want to get a sense of your idea of what is your sense of voltage sags kitna affect karta hai sensitive equipment के functioning में. How much does it cause sensitive equipments to be affected? Okay. So as you see, less than 10% is 1, 10 to 30, 30 to 50, and more than 50% is the choices. So we have, I think, the highest number is in the 10 to 30% bracket right now, that people are saying that voltage sags are responsible for equipment, sensitive equipment functioning, impact sensitive equipment functioning. So I will end this poll. Yeah, it's 1 minute right now. So almost 60% of you say that voltage sags are responsible for between 10 to 30% of impact on sensitive equipment. Now, let me just show you, tell you that voltage sags is the first and most important power quality event. Why? Because 70% of the problems which occur within a facility because of power quality is due to voltage sags. Okay, out of all the power quality events that you saw, okay, voltage sags is the number 1 cause for causing sensitive equipments. When I say sensitive equipments, I'm talking about again variable frequency drives, servers, UPSs, CNCs, anything that is nonlinear or sensitive in nature. Laboratory equipments, in the pharma R&D laboratory equipments like liquid chromatography and so on. That's where these voltage sags are most prevalent and they cause the maximum damage. Okay, and they are typically characterized by a duration between 1 to 4 cycle, typically 20 milliseconds to about 100 milliseconds, in that range, and the depth is between 80 to 50% of the nominal voltage. So this is kind of the way in which you can see this voltage sag being characterized. It has a lower than the nominal voltage magnitude, and for a few milliseconds, for a few hundreds, I would say, or a few tens of milliseconds, to be more apt. So you can see here 4 cycles is the duration, which converts into 4 into 20 milliseconds. That's the duration of 1 cycle, 1 upon 50 seconds, right? And the depth can vary. Typically in the 80 to 90% zone, you will have the most voltage sags which occur because of issues in the utility side, switching, and so on and so forth. And our experience again is that these have caused economic losses from tens to hundreds of thousands of rupees per voltage sag event. Again, we have another session we will take where we will talk about the economic impact of power quality. We have summarized a lot of case studies, a lot of surveys, a lot of landmark studies which have been done across the world, from where we come out with this figure that voltage sags are the number 1, you can say, power quality responsible event for failures of equipments within your premises and facilities. So what is the impact of these voltage sags on certain nonlinear equipment? Very quickly, if I would tell you, an example I take of a of a drive, right? The drive trips on under voltage, right? Why does it trip? Because the utility supply voltage during a voltage sag, right, is goes down, and thus the DC bus voltage, the DC link voltage which you have, the DC link, it transfers the voltage to the inverter. At the inverter, you will have a low DC bus voltage too. And thus it is very difficult for it to maintain a proper motor or a load control at that point of time. And there will be the capacitor is there, which will try to maintain the energy for a certain point of time, but the capacitor may not have that much enough of capacity. The sizing of the capacitor becomes a point of concern at that point of time. So what happens is from a nominal voltage of 660 volt, say DC bus voltage, for example, it goes down at 420 volt, where the trip level of the drive comes on. So this is where you see the manifestation of the voltage sag happening on certain types of non-linear equipment within your facility. So what are the measures in which you can try and reduce the impact of these voltage sags? Again, our focus always is to focus on no cost or low cost measures to protect your equipment first and foremost. So some of these are listed on your screen, which can be most commonly is connect large loads directly to the PCC. Do not have a large compressor motor or something which is connected 2-3 levels down, downstream, all the way down to your, within the, from an MCC or something you're providing it. Connect it directly to the PCC where you have a strong grid available. The fault level is much stronger, and the voltage sag will not cause a significant impact on the other loads within your facility due to the operation of the such large loads. Or you can choose equipment with sag resilience. So sag right through is one of the considerations that you should have while you're selecting or choosing equipment during the design stage. While you're going to buy equipment, while you are trying to replace some equipment, ensure that the vendor is complying to SEMI 47 standards, which are typically the standard which is looked upon by all semiconductor driven equipment for it to be able to ride through a certain voltage sag, right? There are other things also. You can convert a single phase power supply to phase if at all at the lower end, at the smaller equipment levels, for the impact of voltage sags to get reduced, especially if it is a single phase sag, and if it's on that particular phase, the effect will be much more severe as opposed to having it through a face-to-face connection. So like these, there are different ways in which you can try and mitigate the voltage sags without having a significant investment. But yes, at times there are considerations which require you to go for an investment-based solution, in which case you probably need to either do it at the equipment level. Say you have this drive, which is your point of concern, which is experiencing certain malfunctions or failures. That's where you will have this mitigation equipment, a voltage sag mitigation device, or a dynamic sag mitigation device, etc., whatever you call it. There are different names for it installed. Or it can be for a group of equipment, which is the point A. It can be at the entrance of the entire plant, right, which is a costly proposition. But sometimes that's the only option. Or the grid, at the grid level, right? The utility may take up some sag mitigation measures to prevent that from impacting a large volume of customers which are being served and that have critical nonlinear loads. So these are some of the ways in which a voltage sag mitigation can take place through investments in your premises. One case, again, it's a very big case study. I'll not be going into too much detail in this case study in this session. I can talk almost for 30 minutes on this case study, but this is one of the summary slides. This was about a cement plant where they had a typical medium voltage drive, and the drive was tripping due to occurrences of certain amount of magnitude of voltage sags in the plant. And what happened is, over a period of 3 months, okay, a power quality study was conducted, and the occurrence of these, the frequency of occurrence of these voltage sags was plotted, normalized over a certain period of time. If you, as you see over here, in terms of the number of cycles that is plotted over here on the x-axis, and the voltage magnitude that is plotted over the y-axis. And what you see over here is that there were a number of these voltage sags which had a magnitude of about 75% to 90% of the nominal voltage, right? The magnitude of the voltage sag was in that range, whereas some of them, only certain percentage of them, were lesser than 75% of the nominal voltage. So the simplest solution which we could apply over there, and which worked beautifully to prevent almost 60% of the voltage sags from causing a downtime to their medium voltage drive, was to increase the under voltage setting of the medium voltage drive. So the under voltage drive setting was previously kept at about 85%. As you see over here, this dotted line shows the under voltage drive setting, which is 85%. And that just being reduced to 75% caused almost 60% of the voltage sags to stop having an impact on plant downtime or that particular drive malfunctioning. That's the beauty of having a power quality monitoring study being undertaken for a longer duration of time to correlate all these events and decide the threshold setting of what you can do with such kind of a mitigation strategy. Right? So that was one example which I just wanted to show you. There's one more example, one more case study we'll come to very soon. Now, next, and very quickly, we'll just talk about harmonics. As I said, I don't want to dive too much into harmonics, but very simply, yes, harmonics is a manifestation when it comes to the nature of the sinusoidal waveform. It doesn't remain sinusoidal in nature, and you have lot of these non-linear loads today which are responsible for the distortion of these harmonics. Very quickly, I would like to ask you through this poll that you see on your screen. In your opinion, what is the reason that okay, I'm just seeing to launch this poll. Yeah, you can see it on the screen. Do you think harmonics is responsible for electronic equipment failures? How many of you do feel that harmonics is responsible for electronic equipment failures? Okay, so overwhelmingly, I think 86, 90% of people feel that harmonics is responsible for electronic equipment failures. Well, I will end the poll for want of time. We have almost everybody has answered. The good news is that harmonics, in our experience at least, are not responsible very directly for electronic equipment failures. Okay, sorry to bust that myth right now in front of you, because what happens is the impact of harmonics. I'll qualify my statement. Okay, why I say that harmonics are not responsible for electronic equipment failures. If you see the impact on the on all the equipment which you see on this slide where harmonics are causing impact, it's either in terms of higher bills, in terms of production loss, right? Nuisance tripping of breakers. Okay, it's not electronic equipment failures. It is a tripping of breakers because of higher RMS of harmonic current being manifested, or it is due to a generator not being able to start because of having a huge amount of harmonic reach load in the system, or a lower power factor because harmonics can pull your power factor down. It can reduce your power factor, or because of a higher harmonic penalty which the service providers have started levying, like in Tamil Nadu, in Maharashtra, and so all these states. Or it can be reduced service life of equipment because they are like cables, okay, which are bus ducts, which are getting overheated over a period of time, and hence the life of these are reducing. But electronic equipment failure, I want to call that out. The electronic equipment, when I talk about drives, when I talk about anything which is AC to DC conversion, an SMPS, these are meant to operate in a harmonic rich environment. They are the ones who are themselves chopping the sine waveform. They are not going to get affected by harmonics. Let's be very clear. They are the ones who are the culprits, if they were to be called that, to generate these harmonics, to really cause the current waveform to get distorted. When will harmonics cause failures to certain equipments is when the voltage distortion, right, not the current distortion, is increasing because of a high impedance and your very high current harmonics being generated. That's when you have your Ohm's law coming into play, and your high impedance and your high harmonic current causes your voltage harmonic to increase. That's when you can possibly expect equipments to start malfunctioning, but not because of current harmonics. You can expect that your equipment start failing. More often than not, we have found that most of the times downstream, not at the PCC, current harmonics are higher, say near a chiller, right, which is VFD driven, but it is not going to cause any problems to your CNC equipment or something like that, because the voltage harmonics is well within limits. You have almost a sinusoidal waveform. So IEEE 519 2014. Apologies that I have not upgraded this to 2023. The latest standard has also come up, but this table doesn't change largely. There is not much change in this. It brings out the limits for voltage and current harmonics, for distortion limits for facilities. Again, I'll not go into details of this standard, but as I said earlier, these standards are meant to provide you just a ballpark, a benchmarking with respect to where are you sitting, and to comply to certain state specific penalties, if at all there are any, state specific norms, if at all there are any, but nothing further. So this is current harmonic limits, which is measured in terms of total demand distortion and not total harmonic distortion. If at all a lot of you have a feedback to take a separate session on this, we will be more than happy to. And while I say that, please do put in the chat window if you feel that we should expand on any of these topics in much more detail. We'll definitely take that and bring up next sessions to cover these things more in detail. Okay. So for want of time, I'll go quickly further on some case studies. Okay. This is one of the facilities. Okay, I'm sorry, this is not a case study. This is the approach in terms of harmonics that we have been wanting to get your opinion on. So first approach which we see is with respect to an OEM driven approach, where an OEM comes, does the harmonic assessment study, and recommends to the customer that hey, look, your harmonics are so and so, and you need to go for a filter, and this is the size of the filter, this is the size of the active filter, and this is the cost of the filter. This is typically what happens. We have seen large number of times where the customers want a harmonic study to be done. They will call for a OEM who is a manufacturer of the filter, and they'll do the study. What happens is the cost of the study is typically much lower. इंडिया में आज की तारीख में 5,000 रुपए में हार्मोनिक ऑडिट करके लोग देते हैं, एंड सैड पार्ट अबाउट इट, स्टैंडर्ड्स का नॉलेज नहीं होता है, equipment, watch equipment are being used, class A, etc. is not being considered, the approach of the study is not known at all. Whereas there are independent third party entities who do these studies also, and where the approach is very different. There is a detailed historical data collection, there is a detailed monitoring where you collect trends, you collect incidents which have occurred, you correlate that with symptoms which are occurring in your facility. You do it at multiple locations simultaneously, and you do it in multiple scenarios. मतलब एक सिनेरियो में आप हार्मोनिक स्टडी नहीं कर सकते हो. आपका फर्नेस है, अगर if you are a steel rolling mill, then you have different scenarios. If you have a solar farm with solar PV connected to your grid, you have to do the harmonic study in multiple scenarios when the grid is in a islanding mode, when it is connected to your different equipments, when you are on the captive generator. All of these scenarios matter. What is the flow, the power flow that is occurring? What is the severity of the problem that you're facing? What is the true and the displacement power factor that you're experiencing? A lot of these things come into play. And then the question comes is whether or not a filter is required. That's the first thing you need to go for. If at all you need to go for a filter, what can be done to your existing reactive power compensation or filtering that you already have? So that's the approach we typically want people to take, and we find that more often than not the easier way is taken, where just the OEM is asked to take the study, and then 2-3 other quotations are invited, and the study is done. So what happens is the cost of the solution is very high, that you go for. So again, what approach would you choose is something I would love to know your views in the poll which is in front of you. We'll go further because I'm running a bit short of time, but yes, glad to know that independent assessment is being selected, and that's thankful. But yeah, I do see 20 to 25% of people recommending the OEM driven approach. Maybe yes, it will be great to know your responses in the chat as to why you feel that. It will be enlightening for us too. Okay, but this is one case study which you see on the screen, which tells you why OEM study should be avoided at some times. I'm not saying always. If you very well know that you have to go for it, yes, fair enough. But if you really want to understand whether harmonics needs to be addressed or not as a problem, this is what happens. This was a live case where the OEM did the study. They did for it one day. They charged us 10,000 rupees. They proposed 80 lakh rupees solution. Whereas we went there, we did the study for 5 days because we studied from various angles. The cost of the study was 1 lakh, mind you, but the cost of the solution was only 8 lakhs. So that's where we want to highlight that do not get drawn by the cheap cost of the study. That gets subsidized initially for somebody to sell their equipment. You should try and go for unbiased and neutral approach. That's the whole idea. Okay, so few case studies that I want to take up. Again, my apologies. I always end up cramming more slides in my presentation than I should be, and then I don't do justice. That's one learning I will definitely take away. Looking at the time, we're already at 3:30, our promised time of closure. But I hope it's okay that we extend this for another 15-20 minutes. You don't have to pay anything extra. So that's the good news. So, okay. The first case is, this was the case of a pharma laboratory. Okay, they a very high-end laboratory, a very well-known name in the country, and they were facing this challenge where they had installed a UPS and they were feeding to all this equipments which were high-end equipments, LCMS in the pharma parlance, if liquid chromatography, multispectroscopy meters, and yeah, all of the HPLC machines and all. And the challenge was the equipment OEM had refused to do the commissioning unless power quality was assessed, because simply they found neutral to earth voltage beyond 1 to 2 volts. That's what all of these OEMs will harp on. So we went ahead, did a detailed multi-location advanced electrical network health study for a week, in which we deployed multiple analyzers and we captured hundreds of parameters while also looking at site related observations. So we found out several issues related to system earthing, related to the UPS, related to other cross connections also, and unbalancing in the load and so on. And a complete solution strategy was adopted, which allowed the customer to solve this problem even before the facility or the loads were started to be commissioned, and saved them almost more than 1 crore worth of damage to the sensitive equipment. One of the screenshots of some of the measurements that we took in front of your screen, where we did a multi-channel measurements with respect to the power quality, with respect to earthing, with respect to leakages, with respect to ground potentials, at the socket level, at the UPS level, everything simultaneously. So you can see over here, you can see actual fluctuations in the UPS output that was prevalent in the network, the current, and resultantly in the ground potentials also. You see here the socket earthing, where there was a significant amount of leakages which were found, and we had ground potentials rising to almost 5 to 10 volts when there was a correlation with certain dehumidifiers, etc., coming in the system. So these are some of the issues which we recognized and identified by this multi-location and a holistic electrical network health study that we went for. The next case study is a tripping issue. This was again a great case study for doing a remote power quality, continual power quality assessment that was deployed. So at this particular plant, it was a food processing industry. We deployed a power quality remote monitoring system. Okay, it was deployed on the mains, and multiple channels across different feeders were also deployed. The challenge they were facing is a 4,000 ampere breaker was tripping randomly due to a ground fault. That much the facility knew. But why was the ground fault occurring and why was it tripping was not known. Finding and isolating the location of the fault was very important, because it was causing the entire plant to have impact on the production. So what, as I mentioned, we took is we deployed this remote monitoring power quality analyzer, and 8 channels we utilized simultaneously. Without even visiting the site, we could find out the root cause of the problem. We monitored 5 feeders for leakage current. Okay, because ground fault was one of the culprits, but where was it coming from? Whether it was there or not, whether it was a spurious breaker, or because they were thinking of replacing the breaker, right? It's a very costly affair. A 4,000 ampere breaker is not less than 20, something in the range of 5 to 7 lakhs, and with the associated installation costs and so on. So all of this was saved by installing this at multiple channels. The image may not be very clearly visible, but what you see over here is an 800 ampere zero-sum current spike which occurred during the 3rd week of our monitoring, and we were able to isolate from where this was coming. The customer was able to deep dive into that particular feeder, that particular load, and find out the the insulation failure which was occurred and the reason for the ground fault that was coming. Otherwise, it was just a shot in the dark for them. The next case study, I will probably skip this one for want of time. This one, I just will take it very quickly. This was about a 5-star hotel facility where the elevators were malfunctioning, and they were malfunctioning for almost 2 years. Okay, not a small period of time. And what we when we were asked to come in and do a comprehensive power quality management to understand what was going on, we deployed again for a period of a month to 2 months, over a period of such a long period of time and multiple locations. We installed the multiple power quality analyzers. And what you see on the screen is a normalized graph, which was normalized over a 24-hour period. And the blue represents the high level power quality events, which we recorded. And the red represents the number of elevator failures or freeze-ups which are occurring in the words of the customer. You see the strong correlation which came out over a period of almost 2 months with 5 analyzers deployed at multiple locations. We could solve this problem without almost a dime of investment by the customer with a simple tap changing of their OLTC, which was undertaken, not the OLTC, sorry, the offline tap changer, and 70% of these problems disappear. That's the beauty of going for in-depth power quality management or monitoring study, I would say, which throws up all of these correlations which are never so quite visible. The elevator manufacturer also had just told them it's a problem due to mechanical failure or drive failure. They used to replace cards and so on and so forth. So in summary, if I would say why power quality management should be undertaken as a strategy for your facility, is that one is without power quality management, there is no visibility. Events are often missed, misidentified or misinterpreted. बहुत बार हम लोग सुनते हैं कि हाँ सर वो फ्लक्चुएशन आया उसकी वजह से हुआ हो और वो हार्मोनिक्स बहुत ज्यादा है उसकी वजह से ये फेलियर हो रहा है. That's not what is always true. Don't fall victim to OEM or vendor upselling and over engineering. Unfortunately we have found this. Even reputed companies creating a fear psychosis and trying to sell filters or oversizing systems and so on. Solutions are applied one time. There is no dynamics or impending downtime can happen. So all of this, if you want to prevent, you want to get knowledge of the signatures, you want to get alertness of these events occurring, cost optimized, low cost or no cost first, continuous risk assessment, and most importantly, predictive insights. आगे क्या होने वाला है? That is what is more important. मेरे facility में, am I going to be facing a problem or not? Is what is most important, right? And this is a typical strategy to deploy a power quality monitoring, a management strategy, which encompasses not only just voltage and current monitoring, but also temperature, humidity, environmental parameters, along with it, DC voltages for batteries. This is typically for a photovoltaic grid, but it can provide all of these benefits, whether the sag or swell is coming from outside or within my facility. Energy export import. Usme, are there any penalties which are going to happen? Is the temperature, humidity, any impact on asset life? Battery parameters, are they healthy? Impedance, voltage parameters, and so on. Load monitoring, inrush, grid and DER, these distributed energy resources. Are the power quality issues at the edge? What are they? Are they high impedance? Sorry, in-phase closing nahi ho raha hai. Your source impedance high hone ki wajah se there can be certain challenges which you can experience of voltage sags becoming more pronounced and so on. So this is a typical, I would say, a configuration for one type of automated remote power quality monitoring, which can cover a holistic approach with respect to power quality management. And last but not the least, this is a small demo on your screen, which is our small attempt to help industries do this remote automated power quality monitoring using even a portable temporary power quality analyzer. Okay, it's not necessarily required to be permanent, but even if you have a permanent, that can also be integrated with this platform, secure, that I told earlier. But even a portable analyzer can very well be integrated with this platform. So I'll just run this demo very quickly, just a 2-minute demo, and post that we'll open the floor to questions. I've had some questions which were already shared earlier. We'll try to take some of them and take anything live from the audience. So this shows you the schematics of how this remote, power quality monitoring as a service platform works. You take all these ingredients of electricity bill, your analyzers, which has remote monitoring capabilities, which data streaming capabilities it has. It is fed to the secure cloud platform, and you can expect near real-time reports to be generated. So it's a portable remote power monitoring, we say, which can be one of the first kind in India, which is there. It has a live monitoring status of various types of parameters. The one which you're seeing on the screen is a PQ3, which we have integrated. We have other instruments also, which we continuously integrate with this platform of ours. And it can have tremendous amount of insights on your facility on a live basis, on a daily or weekly basis. It can go into events, what kind of events you are having, a sag, a swell, etc. Deep dive or zoom into the event of significance, which you want to understand. You can understand at what time of day it has occurred, what type of event it is, a rapid voltage change, under frequency event, and so on. A live dashboard to view it in real time is also available on any parameters that you want to configure. Phase sequence and live waveform view is available, as well as a frequency spectrum of voltage and current, significant individual harmonics. And then you have these emails, automatic event updates and all, which can be configured to the key people within your facility, to then go over to more detailed analytics or reports, I would say, which are backed by algorithms on the backend, which gives assessments, recommendations, savings or ROI, if at all applicable. All of these are brought part of the dashboard that we will provide to our customers to view these on a live basis and to generate reports on demand of different types of studies and different types of power quality studies. So you can see a complete comprehensive compliance report if you require. As I said, you need not worry about compliance to different standards. Talk about IEEE 1159, IS 17036, 519, and so on and so forth. All of these are inbuilt as part of the platform. Direction of events, where is the event coming from inside the facility, outside the facility, severity of the event, high risk, medium risk, low risk, savings breakdown, if at all there are any mitigations that we are proposing. That's all is automated. Asset health, a capacitor panel health, how is it? That is also integrated. Asset redesign is also part of the platform studies. And this is, in a way, we call it your personal protective analyzer that helps you to overcome these power quality challenges in your facility. So with that, I think I would end my session. Would love for you to have your final poll. I have bothered you a lot with too many polls, and now is the question for you to ask me questions. You can, in the meanwhile, answer these questions on the poll to help you or anything. And meanwhile, we'll take up questions from the audience. So, okay, the first question which I have is sometimes we are facing sensitive equipments like HMI encoder, controller, failure issue after power resume. What is the probable root cause for the same? So yeah, that's very much a potential issue. So in this case, it definitely, since it's identified that it is happening during the start of power phase, after the power is resuming, so it has more than likely to do with a unbalanced neutral or a neutral floating condition, because the neutral is one common link which affects all these equipments. So the neutral grounding, if it is not proper, and not if there are any multiple ground loops within these equipments, that can be one of the possible reasons in our experience that we have come across. Second possibility for these during after power resume is that there is a possibility that your voltage quality has got an effect. The voltage during the startup, okay, there is a sudden loads which are coming in, a lot of inductive loads or these loads are coming in, and it causes the voltage to suddenly drop down at that point of time, or a transient to come in the system, which is of an order of a few microseconds or a few nanoseconds, and that can also be one of the reasons for this problem. We can definitely take it more specific details one-on-one if you so choose to. I'll ask my team to reach out to you. Somebody has asked about the cost of secure and the cost of instrument. So that is it's on a customized basis. We customize this offering based on your needs. It is not a standard off the shelf, because we understand that not everything that we offer as part of secure is something that you will be requiring for. So we will definitely reach out to you. The instrument is a standard three-phase class A IC 61430 analyzer which we use, and these are top of the line instruments. These are all typically in the range of 4 to 7 to 8 lakh rupees. That's the range of these instruments that I can tell you. And these are all very fairly standard in the industry. There may be something in the chats. Okay, voltage flicker due to load are now restricted to plus or minus 1%. Touch base needed in view of power quality. Farqui ji asks in the chat. Sir, voltage flicker due to load are restricted due to plus or minus 1%. When you say yes, for most of the loads, I do agree that they are not exceeding that limits. It's only in the case of loads like induction arc furnaces or some such loads which are very highly fluctuating and variable loads. So VAR compensation, yes, that's one of the most easiest and the cost effective ways to address these flickers, especially for these kind of very fast acting loads. And obviously the starting of these loads, if it can be through drives or soft starters and so on, that will also allow these rapid voltage changes in the voltage to get addressed to a large extent. Okay, earth loop impedance is being asked how it is being measured. Yes, sir, there are standard tools available, equipments available, which is available to measure the earth loop impedance. But what we need to understand is simply measuring the earth loop impedance may not solve the purpose. That's only half of the story. You need to compare it with the protective device with whom you want to compare. Whether the loop impedance is being measured at a socket or it is being measured at a breaker, at a panel level. The immediate upstream protective device that needs to be compared with respect to the loop impedance value that you get, that whether in the case of a probable fault, the protective device will operate within a certain period of time or not, thereby protecting the facility from an imminent disaster or imminent shock hazard or a short circuit fault or so on. THD is now being asked below 3%. Again, Farooqji mentions that question. Sir, that is not true. There is, when you're talking about THD, it applies only to voltage THD. That's where voltage THD is being asked for. And that value is now 8% for anything less than 1000 volts, as per the latest IEEE 519. So voltage THD is required to be kept below 8%. Individual voltage harmonics are lesser than 5%. I'll just go back to my slide so that you can look at that. Yeah, this is your THD values. So you see 8% for voltage THD, 5% for individual voltage harmonics for less than 1 kV, 5% for 1 to 69 kV, that is on HV side, and 3% for individual harmonics. For the current harmonics, they are based on this table, which is a short circuit to load current ratio that determines what is your TDD limits. Your first TDD limit is 5%. If you have a very strong system which is less than 20 is your ratio, and so on and so forth. So the secure allows to do this completely automatically. You don't need to do all this computation by yourself. It will all do this automatically and give you a completely compliant report immediately. So yeah, we will be hosting the recording of this webinar as a YouTube link. It will come to all the participants. Please do feel free to have that as a source of knowledge. Any other questions? I'm just trying to see. There were a few questions which were. Okay, where is the chat window? Sorry, where is my chat window? Yeah. MSCDCL has started writing in sanction letter for Mumbai and area, sir. Yes, unfortunately, I do agree, but there is not much truth to that letter unless and until MSCDCL or rather MERC brings out a mandate in terms of penalizing harmonics. MSCDCL's letter is a letter to take action in the interest of the consumer, in the interest of improving their health. It is not a rule that anybody needs to comply. It is something that is a letter being given in the interest of the consumer to reduce the harmonics. But as I said, you need to be cognizant of whether or not it is exceeding the standards. First and foremost, try and understand whether harmonics are really exceeding or not. So that is more important. PQ is very much related to fire safety, sir. As I mentioned, there are a number of case studies where we have found we have been able to identify incidences where there were significant, say, unbalances in the system. Neutral overheating, for example, was just starting to happen, and that was going to imminently cause either a fire or result in a fire incident. So there are a number of ways in which poor quality can impact or can prevent a fire safety hazard which can occur in your facility. Okay, I'll try to see if I can answer few questions from the audience which were asked earlier before the start of the session. Okay, how can we control leading power factor on real-time base without delays? So that's a good question. For controlling leading power factor on real-time basis without delays, it's exactly the opposite of your capacitor-based compensation. You need an inductive compensation. But nowadays you have these, static voltage. Sorry, not static voltage. What the name eludes me. It's SVG. Sorry, a static var generator, which is a IGBT-based device that can provide compensation both in the all the quadrants, whichever you want. It's a 4-quadrant device. So it can give you inductive as well as capacitive compensation on a millisecond to millisecond basis, which allows the participant to, the end user to have any kind of load being compensated on a real-time basis and trying to achieve almost a unity power factor over there. Right. What are harmonics and how do they affect power quality? Yes, I think we have tried to answer that in a certain way. Harmonics do affect power quality. There's no doubt about it. But yes, how much? It should be taken with a pinch of salt. An OEM telling us that why should harmonics be, harmonics should be addressed. That something should not be there. Okay, going further, impact of PQ and PF, reliability of electric equipment, challenges. Which one is the best instrument to measure harmonic measurement? The best instrument to measure harmonics is it's not best, I would say, as per the standards. IEC 61000-4-30 Class A Edition 3 compliant instruments are only the ones which should be used for measuring harmonics in your facility, so that you do not have any ambiguity and there is no dispute when it comes to sharing that data to anybody, if at all you're doing it for compliance purposes or even for harmonic filter sizing purposes. Okay, how relevant and dollar value can be saved? Somebody has asked how relevant and dollar value can be saved. So yes, as I mentioned, there is a detailed slides which we have on economic benefits of power quality. I would really appreciate if we get ideas on what other areas of the power quality that management that you would love to have in next sessions, which we can take it up as an input. In the meanwhile, benefits in terms of power quality, as I mentioned, voltage sags. Yes, preventing them can really save lakhs of crores of rupees. It depends on the type of industry that you're targeting. It depends on the type of facility you're talking about. If you're talking about a process industry, it can run into crores of rupees. You're talking about a data center, it can again, a financial institution. All of these can have much beyond benefits in terms of one single event saved. Okay, that can help in terms of power quality, because there is no visibility today of what is happening inside your facility, inside your plant. That's the biggest problem. Or even if the visibility is sitting there, it's sitting unutilized. It's sitting in the form of a MFM, but it's sitting unutilized. Okay, one question which had been asked earlier was, in some imported equipment, the input filters are provided. These filters are ignored while sizing the AHFs. Once commissioning is done, the power factor of such equipment goes dramatically down. If such equipment are powered via some UPS, the UPS goes on trip without letting the user know what's the core issue. User size these issues with some base PF. Now question is, do these filters inside equipment tend to attenuate or increase the harmonic levels, which in turn reduces the PF? Okay, that's a lovely question, but I think there is some ambiguity in that. I will like to take this on one-on-one. I definitely have an opinion on that. I will come back to whoever has asked this question. I'll request my team to just note that down. We'll take that question up later on. What should a householder know about power quality? Great question somebody has asked. When it comes to a household, interesting question. Because all my life I've always been focused on industries and buildings. Never thought about power quality inside a house. Yes, unbalance. That's one of the key reasons. Earthing. That's one and the topmost thing that you need to be focused on. Whether the earth, whether first and foremost you have a earth leakage protection at your house, at your residential mains. Is that earth leakage protection device working as per how it should be working? Have you tested? Always that ELCD or RCD will have a test button. Have you gone and pressed that button and checked whether it is working healthy? Does it trip or not? And doing periodic checks with respect to all of these unbalances, with respect to the capacity of the switchgear and the cables that you've installed. You keep on adding more and more loads. So capacity assessment of your infrastructure, of your electrical infrastructure, that is more important. These are some of the things from a household perspective which come to my mind. So I think we have tried to answer quite a lot of questions. It's almost half an hour past our promised deadline. I hope this was okay. There is one more last question to answer. Are these IEEE 519 limits at the grid level? And what is the limits of individual pieces MCs level? So strictly as per IEEE 519, these limits apply only and only to the PCs. They do not apply, nor does IEEE recommend it to be applied to an individual pieces MC. It is the choice of the individual consumer or the measurement person to apply them at a particular point of measurement inside the facility. But remember, that is your choice. The latest IEEE 519 removes that ambiguity and mentions very clearly that IEEE 519 standard is applicable only to the PCC. And remember, the latest 2023 is not a guideline anymore, which was what the 2014 was. Now it is a standard, which is a binding in that sense. I think I would thank you, everyone, for attending our session. Really heartfelt gratitude for taking out your time. I hope we could do some justice, add some value to your knowledge in power quality, and we look forward to your interaction and engagement post the sessions on a one-on-one basis. Thank you, sir. Thank you, Sridharan, sir. Thank you, Rameshji. Thank you, Brijeshji. To Mr. Debashis, I think we will connect with you. This is not the only solution. There are many other solutions that we are providing. We'll be more than happy to connect with you to understand your needs. Any recommendation of do's and don'ts when we have VFDs in line from Mr. Manikchand? Yes, I would say definitely look to ensuring that you are having some kind of input filters when you are having VFDs in line, do not install the VFDs without any input filters in the circuit. Uh, with respect to grounding of the VFDs, that has to be taken special precautions. The proper shielding and etc. is done. The length of the cable from the motors to the VFDs, as much as possible. If it is lesser, that will be great. Copper cabling is more preferable. That's another recommendation. These are some of the things which I can, at the top of my head, I can mention. I can give it to you. On low load conditions, Sunilji, which you are asking for improving power factor on low load conditions, there can be different approaches. It depends on is it a permanent low load situation you're talking about, or it's during certain times of the day you're going with a low load and there is a high load at some points of time. In which case, yes, definitely you need a dynamic, reactive power compensation system, whereby the step size of the reactive power compensation can go as small as maybe 5 kVR or 1 kVR, depending on the load size that you're talking about. So if you have that load size, which is very small, say in the 5 to 10 kilowatt range, then you need it to be compensated with an equally small or equally small capacity of the reactive power compensation steps. Alternatively, if you are looking for a static var generator, an SVG solution can work obviously very well in low load, high load, any kind of situation, because it will mirror the amount of compensation in a stepless manner. It doesn't have steps requirements. It can completely work on a stepless manner in your facility. If anybody has any more questions, please feel free. We are still here for another 2-3 minutes before. There is some in the Q&A. Let me see if I have missed one. Any solution for surges in HT panel 33 kV? So Akshayji, thanks for the question. Sir, when you say surges, again, I would like to understand whether you have any proof or you have recorded these surges. If you have, then we'll love to have those graphs of what kind of surges. Just for information, okay. The term surge doesn't exist now in IEEE's power quality definition. It has been replaced with either a voltage sag, a voltage swell, a voltage transient, and so on. So a surge is a very common word which we use. Yes, I do agree. But what kind of voltage event is there? Based on the ones which I had shared in my presentation, right? Which you saw the number of different ones which you find in a facility. So it can be a dip, it can be transient, it can be a sag, and a flicker, a rapid voltage change. So depending on that, the solution will change. So if it's a transient, there is a very different approach. If it's a voltage sag, it's a different approach. If it's a rapid voltage change, there's a different approach. And more importantly, we would like to understand what problem it is causing to you. Because of that surge in the 33 kV panel, what problem is it causing to you, because of which you're seeking a solution. So we'll definitely love and interact with you on a one-on-one basis. Rameshji, we do not manufacture harmonic filters. Otherwise, I would not be very different from any other filter manufacturer who do studies as well. We purely are a neutral and a third party, auditing agency who will look at the customer's interest first and foremost, try to understand whether or not harmonics is a problem in the first place. If it is not, then we will tell you very plainly, sir, please do not do anything. If it is, we will recommend you the configuration, the type, I would say the capacity and all of these parameters of the harmonic filter, which you can use to approach any reputed manufacturers in the country. We can obviously give you 3 or 4 good names, which we know we have worked in the past, courtesy our experience over the last 22 years. And you can take that further. We can be your partner to ensure that you get the benefits of whatever is for the purpose for which you set out to. That can be done. So a post installation, supervision, verification, etc., can definitely be undertaken. Okay, one question which I missed is voltage sag occur during the starting of the load, and that's common when it's motor short circuit. Is there any other reason for voltage sag? most of the reasons for voltage sags are due to utility level changes or reclosing transmission line faults. These are most of the reasons why voltage sags occur. Within a premise, within a facility, voltage sags occur due to, yes, as you mentioned, a large motor starting up and so on. But most often than not, these are due to utility side faults, utility side phase to line or line to ground, I mean, line to line faults or line to ground, line to line to ground, and different kind of faults which are occurring. One more question which has come is, I am facing issues of voltage fluctuations at distribution transformer site. How can we control or prevent our equipment? Avnishji, we would like to understand a little more in detail because this is at what side? Is it on the HV side? Is it on the LV side? How frequent are the fluctuations which are occurring? What kind of problems and what type of equipment you are having which is having that problem? These are some of the questions we would love to get answers on. And then we can go into more detail. My team will definitely go ahead and connect with you on a one-on-one basis. So I think we will end our session with that. And once again, I thank you everyone for being with us, for joining us. Really appreciate taking out your time and hope we were of some value or we offered some value to you. Look forward to connecting with you in our next sessions very soon.